Hello students, in this session let us learn about what are railway sleepers, functions, their classifications and how the spacing of the sleepers will be provided will be studied in this session. So now we all know what is the sleepers. Sleepers are nothing but the members which are generally laid in the transverse direction to the rails, on which the rails are supported and they are fixed with the help of some of the rail fastening, and the loads from the rails are transferred to the sleeper, and through the sleeper the loads will be transferred onto the ballast and the subgrade below it. Okay, so this is the supporting members to the rails. And next, the functions, what all the functions to be fulfilled by the railway sleeper. So first function is it has to hold the rails to the correct gauge. What is the gauge? The distance between the inner end of the rails. Okay, so when the rails are fitted onto the sleepers, so the rails must hold the rail, the sleepers must hold the rails and the correct gauge has to be maintained. And with the help of the sleepers, it can hold the rails in the proper level or transfer steels to the to provide a firm and even support to the rails. And the sleepers also act as an elastic medium in between the ballast and the rail, so as it will absorb the blows and the vibration of moving loads. So what is the moving loads? Moving loads are because of the trains. Okay, so usually the trains will travel at very high speed. Okay, so while traveling, while the train is in moving condition, certain vibrations will be caused, and also the blows will be caused. Okay, impact blows will be caused. So the sleepers what you have provided, that must act as an elastic medium to absorb those vibrating loads. And also the sleepers must effectively distribute the loads from the rail section to the index area of the ballast underlying it, in case of the normal railway tracks. And if the rail track is there on the bridges, so your the sleepers what has provided, that must effectively transfer the loads from the rails onto the girders. And also the rails provided, that should provide a proper level in the straight track, and proper super elevation has to be maintained on the curves. So this can be maintained with the help of the ballast what we have provided below, that the varying the thickness of the ballast layer what is being provided. So with the help of that you can maintain the super elevation at the curve. And the last function is it has provided in such a way that you can rectify, provide drag geometry during the service life. Okay, so these all the some of the functions to be served by the railway sleepers. So next is the what all the requirement of an ideal sleepers. Okay, first requirement is it must be economical. Means the sleeper what we have used, that should have minimum in initial as well as the maintenance cost. The second requirement is the fitting of the sleeper should be such that they can be easily adjusted during the maintenance operations, such as lifting, easy to lift, packing, removal and the replacement. The third requirement is the weight of the sleeper should not be too heavy. Okay, or should not be the neither excessively light. Okay, it should have a moderate weight for the easy handling. So if the sleepers are very heavy, the handling will be difficult. If it is very light, okay, it may not have a sufficient strength for the load carrying. So the weight should be, the sleeper must have the moderate weight, and the design of the sleeper should be such that the gauge, alignment of the track and the levels of the track can be easily adjusted and maintained. And now it should have a resistance to crushing. Okay, so what is there that the bearing area of the sleepers below the rail seat and over the ballast should be enough to resist the crushing due to the rail seat and the crushing of the ballast underneath the sleepers. And now the coming to the design aspect, the sleepers designs and the spacing should be such that it has to facilitate the easy removal and the replacement of ballast below this. And also the sleeper what we have provided, that must be capable of resisting these shocks and vibration due to passing of heavy loads of high speed trains. So that is one of the functions that is served by the railway sleeper. So that has to be an ideal sleeper must fulfill that function. The next is the design of the sleepers must be such a way that even if it is damaged, okay, during the for any reason, that could be easily replace. And also the during the packing process there should not be any damage to the sleepers material has to be chosen in such a way that there should not be any damage during the packing process. And the last requirement is the design of the sleeper should be such that they are not pushed out easily due to the moving trains, especially the steel sleepers. So these are the some of the requirements to be fulfilled by an ideal sleepers. So next is we have the classification of the sleepers. So the sleepers are classified depending upon the what is the material that is used in the manufacture of the sleepers components. So depending upon that, the sleepers can be classified as wooden sleepers, metal sleepers. Within metal sleepers it can be a cast iron or the steel sleepers. And if the sleepers are made up of concrete sleepers, concrete, we call it as the concrete sleeper. So concrete sleepers can be the reinforced concrete sleepers, or it can also be a pre-stressed concrete sleepers. So we'll look one by one what all the advantages and disadvantages of using the various types of sleepers. The first and foremost one we have is the wooden sleeper. So the picture here shows the wooden sleepers that is used in the construction of the railway track. Okay, so wooden sleepers are said to be regarded as the best among all, and they fulfill almost all the requirement of the ideals sleepers. But the drawback of the wooden sleepers that they have very less ability to wear and tear, and they are subjected to decay and attacked by vermin. Vermin is nothing but the white ants. Okay, and the entire life of the sleepers, wooden sleepers, depends upon the quality and the seasoning of the timber what we have used. So when it comes to the advantages and disadvantages of wooden sleepers, we'll talk about the advantages first. Since the timber is easily available in all the part of the India, we can widely use this. The second is fitting for the wooden sleepers are very few and simple in design and easy to construct. Okay, and these wooden sleepers are able to resist the shock and vibration due to the moving loads, and also that will give some less noisy tracks. And wooden sleepers are light in weight, easy to lay, relay, pack, lift, and also to maintain. And it is suitable for all type of ballast, and overall it will be economical, and also it acts as a good insulators, and the rails are well protected. But the drawback is here. So as I already told you, it is subjected to the wear, the decay, and attacked by the vermins. Okay, and wrapping stresses will be developed. The wooden sleepers can subject to the crack, and splitting can occur, and rail cuttings at the edges that can happen. And also there will be a certain difficulties maintaining the gauge in case of wooden sleepers, and also the track will get easily disturbed under the moving load. Okay, and the wooden sleepers have minimum service life for about 12 to 15 years as compared to the other type of sleeper, and the maintenance cost is high compared to the other type of the sleeper. So these are some of the advantages and the drawbacks of using the wooden sleepers. Now what we drawback we had there that was rectified here in the metal sleepers. Okay, so examples of metal sleeper is shown in the picture here. And due to the growing scarcity of wooden sleepers, so wood is being a scarce material. Because of that, manufacturing wooden sleepers are not that easily available, and wood is also of high cost, but it is having a very short lifespan. Okay, though some of the drawbacks what we seen in the wooden sleeper. To overcome that, we started to manufacture metal sleepers, so that can be of either the cast iron, or we can also use steel in the manufacture of the metal sleepers. So anyways, among those two, cast iron is of a greater use because of its resistance to the corrosion. When it advantages and disadvantages of the metal sleepers are uniform in strength, and it has very good durability. And metals in the metal sleeper, the performance of the fittings, railway fittings, is better, and hence the less creep occurs. And metal sleepers are also economical, as it is having a longer life, and the maintenance is also much easy here. And the gauges can be easily adjusted and maintained, and the frequent renewal is not required in case of the metal sleeper. And the metal since the metal also has the good scrap value, easy to manufacture, and it is not susceptible to any kind of fire hazards. Okay, but the drawback here is the most of the metal more ballast is required compared to the other type of the sleepers. And also fittings required are greater in number, and it is difficult to maintain and inspect. And metal sleepers are liable to corrosion, but if you use the cast iron, it is less susceptible to the corrosion that can be done. And metal is being a very good conductor of electricity, and it will sometimes interfere with the track circuiting. And these are very unsuitable for the bridges, level cross, and in the case of the points and crossing. And these are suitable only for the stone ballast. So if you are using any other ballast layer, so use of metal sleeper is not advisable. Okay, and the rails are rails which they are manufactured. Looking to the so the next is the concrete sleepers. The next is the one most widely used. Okay, so this will be made up of concrete sleepers. Will be made up of the strong homogeneous material. So we know what is a concrete. It is a mixture of coarse aggregate, fine aggregate, cement, and the water. When you mix it homogeneously, it will forms a concrete. Okay, and then it will be impervious to the effect of moisture, and it is unaffected by any chemical attack. There is no corrosion, no decay, nothing. Okay, and atmospheric gases cannot decay your concrete sleepers, and also subsoil salts will not affect in any way with the functioning of the sleepers. And the manufacturing is also easy, because concrete can be easily molded to the required size and shape, and it is also withstanding high stresses produced by the fast and heavy traffic. When you look into the benefits, so we have a lot of benefits with the concrete sleepers. Anyways, the concrete sleepers are the one which are been mostly used. Okay, so these are free from the natural decay and attacks by the vermins, unlike the wooden sleepers. And it has maximum service life of 40 to 60 years, and these are not affected by the moisture chemical action of the ballast in the subsoil. And there is no difficulty in maintaining the track circuit, because concrete is a bad conductor of electricity. You can easily maintain the track circuits. And also increased weight of the concrete sleeper reduces the joints maintenance, and the track will have the greater stability and better resistance against the temperature variations. And the concrete sleepers will have higher elastic modulus, and hence it can withstand the stresses induced by the fast and heavy traffic. Okay, and also it is an ideal track with respect to the maintenance of the gauge, cross level, and the alignment. Right, but the drawback here, the weight is one of the major drawback here. Okay, the weight of the one concrete sleeper is almost as equivalent to the 2.5 to 3 times that of the wooden sleepers. Okay, and handling is little difficult, and the mechanical appliances are required for handling the concrete sleepers. Okay, so these are requires pads and pucks for the spikes, and also the concrete sleepers are expected to get damaged the bottom edge during the packing process, and the scrap value is almost nil. But wood and the metal sleepers, they both have very good scrap value, but concrete doesn't have any depreciation cost is zero. And the damage to the concrete sleepers are very heavy in case of derailment, and it may require the frequent change of the concrete sleepers. Okay, so these are the benefits and the drawbacks of using the various types of railway sleepers in the construction of the railway tracks. So now let us understand how the sleeper spacings will be provided and what is the mean how the sleeper density has to be maintained. So now we all know what is the spacing of the sleeper. So spacing is nothing, these are the rails and the sleepers what you have provided. So the distance between the two consecutive sleepers, that we call it as the sleeper spacing. Okay, so that is what given here, the space between the two adjacent sleepers. Okay, that we call it as the sleeper spacing, and that sleeper spacing will determine the effective span of the rail over the sleepers. Okay, and also the space of the sleepers in the track depends upon the axle load which the track is expected to carry, and also the lateral thrust of the locomotive which it is subjected. Okay, so usually the number of sleepers is expressed in terms of number of sleepers per rail length. So that means to say that usually the what is the length of rail, so that depends upon whether it is broad gauge or meter gauge. So usually the broad gauge will have the length of 30 meters. Now for this 30-meter length, how many numbers of sleepers we require? So that is what it says. Okay, so the number of sleepers in the track is nothing but how many sleepers you need to be provided for one particular rail length, and the length of the rail, that depends upon whether it is a broad gauge or meter gauge. Okay, and since the sleepers also provides the lateral stability to the track, more the number of sleepers, more will be the lateral stability. However, we cannot simply increase the number of sleepers definitely, as there is a certain minimum space between the sleeper is required for the packing of the ballast. Okay, so we have to maintain that minimum spacing for the ballast so that it can effectively transfers the load to the ballast. Okay, so now how many sleepers need to be provided, what is the maximum number, and what is the number? Okay, so that will be defined with respect to the sleeper density. So number of the in India, so what number of sleepers what we have provided, nothing but the sleepers density that is provided with using the relationship that is between the what number of sleepers you provided, that varies from m plus 4 to m plus 7 for the main tracks. So now what is this m plus 4, where m is equal to length of rails in meter. So if the length of rails is 12 meters, so what is the number of sleepers that require? Sleepers will be equal to 12 plus 4 to 12 plus 7. So what number we will get? 16 to 12 plus 7 is 19. So we require number of sleepers will vary between 16 to 19 for a rail length of 12 meter. So that is what it says. So with that we can define the sleeper density as what is the number of sleepers per rail length. Okay, so that we call it as the sleeper density, and it is specified as m plus x, where m is equal to length of rail in meters and x is the a number that will vary according to the factors. So in India, we have fixed the value of x is in that will be in between m plus 4 to m plus 7. So depending upon the lateral thrust or the stability of the track was being expected. And one more thing, more the number of sleeper, more will be the lateral stability. Okay, so some of the factors which will governs the sleeper density or axle load. More the axle load, more the sleeper density, more will be the value of x. Speed, type and section of the rails and type of the ballast used and the ballast cushion, type and strength of the sleepers and nature of condition. So all these factors will governs the value of x. Okay, the space and also the spacing between the sleepers is not uniform. Okay, so throughout the length of the track we don't provide the uniform spacing. Okay, so usually 3 to 4 sleepers on either side of the joints are kept close together. So how does it turn? See, this is my first rail section. We have a joint at this point and it is continued with the next sleeper. So usually in the middle the equal spacing is maintained, but when it comes to close to the joints, 3 to 4 sleepers are placed at the closer spacing. Okay, because the joints are the weakest point. Since the impact load will be caused here, that additional stability is required. So that is why the sleeper spacing is reduced when it approaches to the joint section. Okay, so depending upon the sleepers density, the spacing of the joints can be fixed. Okay, so we'll look into the example, one of the example for the calculation of how the sleeper density is calculated. So they are given it as found out the expression for the sleeper density. So how do you get the general expression is m plus s? So we have to determine this. So find out the expression for sleeper density on a broad gauge track if 19 sleepers are used under the rail length. So for the broad gauge track, what is the length of the sleepers? So we'll say about 13 meter, and the sleeper density is expressed as m plus x. So now the number of m is the rail length and x is the factors that depends upon that. So that is what we have to find out. So in the problem they have given if the track 19 sleepers are used, nothing but the sleeper density. Sleeper density is 19, with length of the track is 13, plus we have to find out the value of x here. So x will be 6. Okay, so that's the expression for the sleeper density will be n plus 16. So if you substitute value of length plus 6, that will be equivalent to the, so that is how you can obtain the value. So this value will become 19. So we can obtain the sleeper density with the help of this expression. So another example is they have given sleeper density value is given. We have to find out the number of sleepers required for constructing the railway track of 640 meters. So they have given the length of track is 640 meter long. Okay, so now what the sleeper density, when we calculate the sleeper density, that we will calculate number of sleepers per rail length. So now for one rail length, how many sleeper we will get, that you calculate. Okay, and next for 640 meters, how many rails is required. Okay, that need to be determined. So multiply those two values, you will easily get how many numbers of sleepers is required. So we'll take the total track length is 640 meter. For the broad gauge track, the length of the track is 12.8. You can even take 13 meters. So total number of rails is required. What is that? 640 divided by 12.6. So we require around 50 number of rails for 640 meter long railway track. So they have given the expression for the sleeper density as m plus 5. So substitute the length of the rail. So we will get it around number of sleepers under each rail. Under one rail we require 18 number of sleepers, but we have 15 such rails to cover 640-meter length. So total number of sleepers required will be 18 multiplied by 50, that is equal to 900 sleepers. So this is how, with the having the expression for the sleeper density, we can calculate the number of sleepers required in the construction of the railway track. Okay, so and last thing is, the sleeper density can also be expressed in terms of number of sleepers per kilometer. So this will be used when the railway tracks or joints are welded. Okay, so depending upon the um, whether the track is short welded track or the long welded track, so we have the sleepers density. So sleepers density can be around 1660 meter per kilometer for the center to center of the spacing of the sleepers. Okay, so that should be around 60 centimeter, and we require 1540 sleepers per kilometer, having a spacing between the 65 centimeter. Similarly, if it is for the short welded track, the same sleeper density, but the distance between the two sleeper is 66 centimeter. And whereas when we have one more sleeper density providing 1310 per kilometer of the railway tracks, but there is no recommendation here for long welded tracks, so because we cannot use that. Only this sleepers density can be used for the short welded track, having a spacing between 78 centimeter. So this is how we can provide the sleeper spacing when construction of the railway track. Thank you everyone.